This is Friday night's homework, Module 6, Lesson 10, and it tells us to use the coordinate plane below to complete the following tasks. Line P, this one, represents the rule x and y are equal. So x and y are equal. Another way of saying that is y equals x times 1, because anything times 1 gives you the same number, so that would make them equal. B asks us to construct a line V that contains the origin, which is 0, 0, and point V. So our line needs to have the origin and point V in it. So just line up your ruler or straight edge from a paper, whatever you have, and draw your line. There, and we'll label it V. So we've done this and this. Now we need to name 3 points on this line. So let's see what our grid is counting by. 0, 1, 2, 3, 4, 5. So it looks like it's just counting by ones. So we need to name 3 points on line V. So let's just choose a x coordinate. How about 1? And see where it lines up with y on the line. So go up, and it hits the line right here, which is at 2. So 1, 2. Let's do another one. How about 2, which goes up to 4. You just go to the x coordinate and follow it till you hit the line that you're looking at. And that looks like it's 3, 6. And you don't have to do them all down here. You could do them up here. But just make sure it's where you can tell what it's going to be on the line. So now we have to identify a rule from looking at the pattern between x and y in each one of these coordinate pairs. We need to identify a rule that describes line V, because we know if we have a rule and a coordinate pair fits the rule, it will be on this line, even if we can't see it and it's up here. So let's see. We know that the x coordinate looks like it's smaller in each one of these. So it could be adding 1, but let's see if that works here. 2 plus 1 is 3, so that doesn't work. But it kind of looks like we've doubled each one. So let's do that. Y is x times 2. And there's a few ways you could write that. I think this will be probably the most efficient way to write it, but you could do x times 2 equals y, or x doubled is y, or x is half of y, but this is probably the one we're looking for today. So looking at my line, I notice it goes through the origin, so I'm already thinking before I make that rule that it's probably a multiplication rule, so that's why this is good to have it as multiplication. Now E tells us to construct a line W that contains the origin and point W. So same thing, line up your ruler with 0 and W and connect it and label it W. And I'm going to put the rule over here. This was x times 2. And we knew this one was x times 1 because it was equal. And then we're going to work on finding this one. So we've done that. Now we got to name 3 points on that line just like we did earlier. So let's do the same thing. I'm going to go to one of my x coordinates and go up till I hit it. So 2, 1. 4, 2, and we could go to 3, and it's kind of in the middle there, so 3, 1.5, and you just have to do 3, but you can keep going. Maybe I do 10, 5, that's where my W is. Alright, oops, sorry, I didn't realize that was not on the screen. So let's identify a rule to describe W. Once again, this one goes through the origin, so I'm thinking since it's going through the origin and it's not parallel with my lines, it's probably going to be a multiplication rule, but let's see. It's 2 to 1, 4 to 2, 3 to 1.5, 10 to 5. So some of you might be able to pick out the pattern just like that, but if not, let's go through some strategies to figure it out. So x is bigger in each one of these, so let's try and spot the pattern. So from 2 to 1, it could be subtract 1, or it could be half it. Let's see what works. 4 minus 1 is 3, so that doesn't work. But if we half 4, that works. 3 divided by 2 is 1.5, and 10 divided by 2 is 5. So I think that it's probably we need to half it or divide by 2. So what are some other ways we could say that? Well, y is 1/2 of x, and that's still multiplication. Of, remember, means multiplication. So I'm going to keep my rule like that because I notice it's probably going to be a multiplication rule. Now I need to compare and contrast lines V and W in terms of their relationship to P. So it should be comparing them to each other as they are related to P. So how are these both similar to P? Well, they all go through the origin. All the lines go through the origin, which is at 0, 0. So that's how they are the same. Is there anything else that's the same? Well, they all are multiplication rules. All the lines have multiplication rules. So now we've compared it. Let's contrast them as they're related to P. Well, it looks like line X is steeper than P. Line X is steeper than P. While line, oh, not line X, it's line V, I'm sorry. Line V is steeper than P, and line W seems to be shallower. So line V is steeper than P, while line W is shallower than P. All right, now our last one is, what patterns do you see in lines that are generated by multiplication rules? Well, all three of these were multiplication rules, so let's see what the pattern is. We've talked about this in class for a couple days. So this one was x times 2, this one is x times 1, and this was x times 1/2. So we know they all go through the origin. And it seems like the bigger the number you multiply, so 2, the steeper the line, because this is bigger than this, and this is bigger than that, so that makes it steeper each time if you multiply a higher number. So the higher the number you multiply, the steeper your line, and that would consequently mean the higher your y values are. So we know that those are the rules of multiplication. If these were addition rules, they would be parallel, so they wouldn't be steeper. They'd all be the same because they'd be parallel. It's just the higher it is on the chart is the higher numbers that you're adding, and the less you add, the lower it is on the chart.